In this video, we're going to learn how to graph a log function. And so we're going to start out by graphing the log base 2 of x. I'm going to go ahead and write it as y equal the log base 2 of x. And the easiest way to graph it is to change it into its exponential form and then build a table. So in this case, 2 is my base. The y would become my power, and we would say that that is equal to x. So we are going to build a table where we are actually plugging in for the y values so that we can find x. So I'm going to start with a y value of negative 2. So when I take 2, the base of 2, and raise it to the power of negative 2, remember the negative powers flip the base. So 2 over 1 will become 1 over 2. And then the power is now positive, so 1 over 2 squared is 1/4. So up here on my graph, when x is a fourth, my y is down at negative 2. So then I'm going to use a y value of negative 1. 2 to the negative first would become 1 over 2 to the first, so that's just a half. So when I go plot that, when x is a half, my y is negative 1. Then y will be 0, so 2 to the 0 is going to be 1. So when x is 1, my y is 0. And then when y is 1, 2 to the first is 2. So an x value of 2 gave me a y value of 1. And then when y is 2, 2 squared would give me 4. So that would be the point 4, comma 2. So this would represent the graph of the log base 2 of x. Now, the first question, or the next thing that they asked me to do is we're going to use transformations to create g of x. So let me switch colors here for a minute. Remember, anytime that something is added or subtracted to your x, it's going to create a horizontal shift, and it is opposite your sign. And so because we see plus 3, that means all of our points are going to go to the left by 3. So this 1, 0 will now be at negative 2, 0. The 2, comma 1 is now going to be at negative 1, comma 1. And then the 4, comma 2 is now going to be at 1, comma 2. So everything got shifted to the left by 3 units. So there's my new graph. So notice what happened on the original graph. We had a vertical asymptote, we would say is the line x equals 0, because we were getting closer and closer and closer to that particular x value. But now that we have shifted 3 to the left, what's happened is we're now going to say that vertical asymptote is at x equals negative 3. Okay, so the original domain on my graph, we would have said was from 0 to infinity, since it starts close to 0 and goes all the way to the right. So that's my original domain. So now by shifting the graph 3 to the left, what's happened is that domain now starts at negative 3 and goes to infinity. So it does not touch the negative 3. And then the range of the original function was all real numbers, because we see an arrow going down to negative infinity, and then we're going up to positive. So my original range is negative infinity to positive. The left, it did not change that original range. That range is still going to be from negative infinity to positive infinity.